All right, let's take a look at section 6.3, which is about logarithms and logarithmic functions. We are going to split this up into 2 days. There's a lot of information going on here. Uh, in the first part, we're going to take a look primarily at the equations and what we could do with these logarithmic equations or functions. And then we'll get to graphing in day 2 and some more additional things with solving equations. Let's take a look right here and start off by looking at the logarithm of y with base b function. Well, what does all of that mean? When you see what I have there, it says log, and I'll read that as log base b of y. Okay, so when they say logarithm of y with base b function, you're pretty much taking a look at the equation that is set up right here, or the expression, and that's what that means. Log base b of y, or logarithm of y with base b function. Our next term we have right here is the common logarithm. Now, logarithm is the full term of log. You've heard of log, or you may have seen log, especially on your calculator. So what does log mean? That is the same thing as logarithm, just to kind of get that, make that clear for you. So a common logarithm is a log with base 10. And log base 10 or log itself. On your calculator, you will typically see the word log. Now, that automatically notates log base of 10. Most scientific calculators, if the base is not 10, you can't really use your calculator to solve a logarithm. Now there are a few steps that we could that I'll show you later on how we can use the calculator to solve a logarithm that does not have a base of 10. But one thing that you need to know is that your calculator, when you use a logarithm function, it is assuming that the log base is of 10. So don't automatically think that you could use your calculator to solve everything at face value. Let's take a look at our next term, which is natural logarithm, or what we use in the calculator is ln. So ln represents your natural log. That is a log with base e, or, like I just mentioned, ln. So we start talking about what is a logarithm. We haven't gotten into full detail quite yet. There's one more thing I want to share with you, and I'll get to that in a bit. Before we get there, let's take a look at the core concept, the definition of a logarithm with base b. So it says right here, let b and y be positive real numbers with b cannot equal 1. The logarithm with y of y with base b is denoted as log base by, as defined as what we have right here. Log base b of y is equal to x if and only if b to the x power is equal to y. So one of the things that you're going to be able to do is take these two expressions, and you're going to have to rewrite it into either an exponential, or you could take an exponential function or equation and write it as a logarithm. Okay, so it says the expression log base b of y is read as log base b of y. Okay, if I give you an example right here, let's go ahead and I'll put log. So instead of just letters, we'll put log, and I'll put subscript 5, and then I'll put a 10 next to that. So log subscript 5, 10, that right there, once again, what I'm trying to have you understand That means log base 5 of 10. That's how you could go ahead and rewrite all of that right here. All right, so now that we have an idea of how we could take the two equations and rewrite them, in our student journal, let me go back a few pages and take a look right here. It is on page 164. And take a look at this essential question. We don't normally take a look at some of this stuff, but in this section, it helps us understand, well, what is a logarithm? It says, what are some of the characteristics of the graph of a logarithmic function? And it says, for every exponential function of the form f of x is equal to b to the x power, where b is a positive real number other than 1, has an inverse function that can be denoted by g of x is equal to log base b of x. So why did I send you here? Why are we looking at this? Because what is a logarithm? It is the inverse function of an exponential function. Okay, so in 6.1 and 2, we were starting to look at exponential functions. Right here in 6.3, we deal with logarithms because those logarithms are inverses of these exponential functions. All right, so we're working with a partner. So you'll be working by yourself right here. It says, find the value of x in each exponential function, explain your reasoning, then use the value of x to rewrite the exponential equation in its equivalent function, equivalent logarithmic form of x is equal to log base b of y. So what we're going to do is take these exponential equations and we're going to write it as a logarithmic function. Okay, so let's go ahead and do that. Once again, we take a look at the two functions right here. And here is the basic exponential function. We have f of x is equal to b to the x power. So you got to make sure that you take a look at both of these functions and see, all right, where does the b go? Where does the y go? Where does the x go? And then start rewriting things. The function right here, remember, once again, we're taking a look at, if I were to take this and rewrite it as b of x is equal to y. Because remember, f of x, same as y. We take this function up right here, and we're going to write it as a logarithm. Well, where is the b? If I take a look right here, the b is exactly where the same spot as the 2, which happens to be your base. So when I write this, I'll go ahead and start off with log, and then my base will be 2 of y. Well, do I know what y is? Right here, y is right, when I wrote it in blue, it's right below where the, or right where the spot of the 8 is. So log base 2 of 8, and that's equal to, and where am I getting this next? Of x. And that's how you go ahead and rewrite your function. Okay, so to go from exponential to logarithm is what I'm showing you right here in number 1. Let's repeat. Let's try it again on letter B. Okay, so we'll rewrite this. I see my base is 3. So I'm going to go ahead and start this as log base 3 of 9 is equal to x. So once again, if we were to, let me draw some lines, you see there's the base, the x is over here, and what it's equal to went right there. All right, so it's a matter of practicing and just kind of figuring out, all right, these are the two equations I'm looking at, and where do I plug things in when I rewrite the inverse or the logarithmic equation, equivalent. So let's try this again. Right here, for letter C, I could put this as log base of 4. And remember, that 4 to the x power, 4 is the base. So think about it that way. Log base b, so that's why we have the 4, of 2 is equal to x. All right, so now we have all of that right there. I think we're in pretty good shape as far as being able to take it from exponential to logarithmic function. All right, let's take a look at the extra practice. So let's go to number 1. We'll come back to graphing, don't forget, on the next lesson in 6.3b. So we have right here log base 10 of 1000 is equal to 3. And remember, we have our equations that we're taking a look at as far as, I guess, what is it? From logarithmic to an exponential function. Remember, the setup is this. We have log base b of x, or sorry, base b of y is equal to x. And then the exponential function is your base to the x power is equal to y. So right now, if you look at number 1, it's log base 10 of 1000 is equal to 3. It's looking like the log base b of y is equal to x. We want to change that to the exponential form of b to the x power is equal to y. So we'll go ahead. I know that my base is 10 right there. So I'll go ahead and write the 10 first. The exponent is x. So x happens to be right here. We'll put 3, and that's equal to 1000. And if you think about it, it does make sense. 10 to the third power is 1000. 10 times 10 times 10 equals 1000, and it all works out. All right, taking a look next up at number 2. We have a base of 5. So we'll write the 5 first. We have our exponent is y, so negative 2, and that's equal to 1 over 25. Does it work? Well, remember, we don't typically want negative exponents. So does this really equal each other? Remember, if I don't want a negative exponent, I'll rewrite that 5 to the negative second power down as 1 over 5 to the second, which equals 25. And therefore, we get 1 over 25. All right. Number 3, we have our base of 10. So I'll write that first. We have my exponent is y, which is 0, and that is equal to x, which will be 1. And 10 to the 0 power equals 1. We have our exponent rules that we went over already in chapter 5. And then take a look at number 4 right here. Okay, this one gets a little interesting. We have ourselves 1/4 is the base. The exponent is to the negative third power, and that's equal to 64. All right, and there you go. Now, if I were to take we don't want negative exponents, what we end up doing is we take the inverse of 1/4, which will be 4. And that'll take this and turn it into 4 to the third power, which would be getting us 64. All right, so there you have us dealing with these logarithms right here, going from logarithmic to exponential. What I showed you just before this was exponential turning it into a logarithm. All right, let's go ahead and continue on. And we're going to rewrite the equation in logarithmic form. So pretty much what I showed you in the very beginning. You can go ahead and go through these quickly. Let's, for the sake of helping you guys out, we got log base b of y is equal to x, and then we have ourselves our b to the y power, or sorry, b to the x power is equal to y. And so we have our two equations that we're going to use to help us go from logarithmic to exponential, exponential to logarithm. So let's do it. We've got ourselves 2 to the second, or 12 to the second power is equal to 144. Okay, that sounds true because 12 squared, 12 times 12 is 144. But that's not what I want right now. I want to take this exponential and write it as a logarithm. So my base is 12. So we'll write this as log base 12 of 144 is equal to 2. And that's the rewrite. Let's take a look at number 6. We've got now, we'll rewrite this as log, the base is 20, and we'll put of 1 over 20, and that's equal to negative 1. For number 7, I look at the base, and that's 216. So I'll start off and put log base 216 of 6, which is your y, and that's equal to 1/3. All right. And then finally, on number 8, we have log, the base is 4, it's of 1, and that is equal to 0. So we now have written once again from exponential to logarithmic form in numbers 5 through 8. Next up, let's take a look at number 9. We will evaluate the logarithm here. So we have it in logarithmic form. So what we're trying to do is figure out, well, what exactly happens to be x. So let's see what we can do here. Let's go ahead and take the logarithm and go ahead and rewrite it as an exponential. So as I look at the problem, we have log base 4 of 64. And typically, this is equal to, we have right there x, right? If I were to take this and write it as a logarithmic function, it's log base 4 of 64, which happens to be y, is equal to x. There's no x there, but I'm going to write it down. And so what I'm going to do next is let's rewrite our function into an exponential. And so we have our log base of 4. We'll rewrite it to the x power and set that equal to 64. So what do we do here? Okay. One of the key things that if I want to be able to solve for a variable that happens to be one of my exponents, I need the log bases to be the same. So one of the rules, and what we're going to start taking a look at here, is that if the log bases are the same, or if the bases are the same, then all I all I need to look at are the exponents and set the exponents equal to each other. So with this 64 right here, I could rewrite this 64 as 4 to the third power. And you're saying, well, how did I do that? Why did I do that? Well, think if the base on the left side is 4, then there's a good chance, okay, not all the time, but a very good chance that the base on the other side, which where the 64 is, possibly will be 4. And 4 to the third right there happens to be 64. Once the bases are the same right here, I will go ahead and set the exponents equal to each other and end up with x is equal to 3. And just like that, we've solved number 9. Let's take a look next up at number 10. Okay, so we'll go ahead, we'll set this equal to x, and I'll rewrite this logarithm in exponent as an exponential. And so I have 1 over 8 to the x power is equal to 1. Well, this one right here, I can't take that 1/8, or I can't even take that base of 1 and somehow turn that into 1/8 in any way. But remember, your exponential rules, that's where they come into play right here. A number other than 1, or sorry, 0, if 0 as the base, raised to the 0 power ends up equaling 1. So right here, we can go ahead and put x is equal to 0. 1/8 to the 0 power is 1. Remember, 1,000,000 to the 0 power equals 1. So remembering your rules for logarithms, or sorry, exponents, almost everything raised to the 0 power is equal to 1. And therefore right here, our answer will be 0. Let's go ahead and go to number 11. We have right here, once again, we'll set this equal to x, and let's rewrite this. I now have 2 to the x power is equal to 1 over 32. All right, this looks like a little bit of trouble right here. Looks like trouble, but I think we can get through this. Let's start off and think, well, what could I do with that 1 over 32? Can I somehow turn it into a base of 2? Is that possible? Not quite as it's written will we be able to do that. What I can do right here is this. Let's take this 1 over 32 and rewrite it as 32 to the negative first power. Aha. Now we might be in business. Can I now take that 32 and do something with it where I have a base of 2? And I can. 32 right here ends up equaling, and I'll rewrite this 32 as 2 to the 5th power. Let's actually put this over here to the side. You might want to actually need a separate sheet of paper. Hopefully you're doing it on a separate sheet of paper. Because as you can see, I am running out of space. And I'm going to need this space later on down below when we get to those problems the next day. So we have the same base. Fantastic. Now, since I have the bases being the same, what I will do now is just take the exponents and set it equal to each other. Now, with that 2 to the 5th power, remember, when I raise a power to a power, you multiply. So my answer right here is x is equal to -5. And there you have your answer to number 11. All right, and then next up, let's take a look at 12. Let's see what we can do here. We'll rewrite this. And I'll put my base of 1 over 25. I will raise that to the x power and set this equal to 1 over 5. Okay, I've got a base of 1 over 25. I've got a base of, and a base of 1/5. What can I do? What can I do? Can I turn that 1 over 25 and get a base of 1/5 or 1 over 5? Or can I take that 1 over 5 and somehow turn that into 1 over 25? What I could do right here is take that 1/5. Let's raise that to the second power, because now that ends up becoming 1 over 25. All right. So if I go ahead, realizing, hey, that turns into 1 over 25. And let's see here. Actually, let's go back one step right here. Let's take that 1 over 25 and rewrite. Let's see, how can I rewrite that as 1/5? All right. And by taking this 1 over 25, here we go, we'll take this as 1 over 5, and then we'll raise this to the second power. And then remember that x still is there, and that's equal to 1/5. Now this looks a lot better. Okay, so I went ahead and fixed that. Okay, so we have done that now, and then we can go ahead, now that the bases are the same, we can go ahead and take the exponents and set that equal to each other. And you're saying, well, what's the exponent right here on that 1/5? It's to the first power. So now the bases are the same. I have 2x is equal to 1. Divide both sides by 2. And I have x is equal to 1/2. All right, so a lot of things going on right here. We learned a lot about changing an exponent to a logarithm to an exponent in exponent form. We'll continue to do that in the next section, or 6.3b. All right, so that right there will be important, and we'll go ahead and continue on next time with graphing and some other fun stuff with logarithms.